Hi folks, welcome to Open Analysis Live. We're back again, like a month hiatus since our last video. I did see the sad Pablo meme on Twitter. Breaking my heart, bro. I see ya. But we have been working pretty hard on this special project. It's basically taking all of our free time now, in addition to our demanding day jobs. So you guys are gonna have to be patient for these videos. It's not that I don't want to make them or I've gotten bored of this or anything like that. It's just that we have this other project which we really want to release soon. We're super close to making this public. Some of you probably already know what it is, but we're really close to releasing it. So bear with us. But today we're going to talk about how to use IDA to automate the import building for REvil. And this is the third part in a three-part tutorial series we've done. The first part, we unpacked it. The second part, we figured out how they were doing the dynamic imports. We reverse engineered the hashing algorithm that they were using and built our own Python script. So that's where we're starting this tutorial. And in this tutorial, I'm going to show you how to build an IDA script to automatically decipher all of the hashed imports and label them in your IDB so that then you have a nice IDB with imports that you can start reverse engineering. So that's what we're going to talk about today. Now, I will put links to the first two videos in the description of this video below. So if you guys haven't seen those, go check them out first because they're going to give you the backstory for what we're doing today. So just a recap of where we left off. Whoa, that's bright. Here's our IDB that we marked up in the last video. So here's where they're building the imports. They have this little function that we reverse engineered right here that has some hashing in it. Here, if I'll just F5 it for you guys so you can see it easier. So they have this algorithm here that they use. And if we scroll down to the bottom, we can see what they do is they actually load libraries, DLLs from Windows. They enumerate all of the exports from the DLL in the export directory. So this is in the PE file of the DLL. They can list all the exports. For each export, they actually hash the export and then compare it against the list of hashes that they have in the PE file. And if the hash matches, then they replace it with the jump to the API call. So we went over that in the last video. This is just a quick recap. And if we look back here, this was the list of hashes that we found in the PE file. So each one of these is a hash that represents the hash name of the API name or the export from the DLL that they want to resolve. And if we pull up our script from last time, this is where we left off in the last video. We reverse engineered the function that they use to actually hash the API name, and we reverse engineered a small transform that they use on those listed hashes here. And we confirm this by reversing this first hash here, which is OB6D391AE, and we found that that actually maps up with WSPrintf. So that's what we did in the last video. That just brings us up to speed here. So now that we're caught up, what we're going to do in this video is we are first going to do a bit of Python scripting, which is kind of boring and I don't see a lot of point in going through it step by step. So I've already built some scripts and I'm just going to talk you guys through them. I'll also put them on my gist in GitHub so that you guys can check them out and use them yourself. But what we're going to do is we're going to build two scripts today. So the first one is going to enumerate a bunch of Windows DLLs and take all the export names. So these are the API names like, create process internal, et cetera, and it's going to just create a big long dictionary of all those names. Because of course we have to brute force these hashes. We have to create a lookup for each one of these hashes. And we don't know which API names are going to be used in this list here. So we have to basically make a list of all of them, which don't worry, with Python, it's pretty fast. And then what we're going to do is we're going to make a lookup script in IDA that will look up these hashes one by one. So the first script that we build is the one that is going to build this list of exports or a list of API names. And that I've already built for you because it's pretty simple and straightforward. And it's going to be boring if we have to do it all piece by piece here. So I called it exports.py, and here's what it looks like. And I'll just walk you guys through it. So the first thing we have is we have a list of interesting DLLs. So this I actually stole from another Python script. It's actually from a tool from the FireEye Flare GitHub repository. And this is a list of reverse engineering tools that are super helpful. And I'll actually link this one in the description below. What this tool does is it does a generic version of what I'm showing you guys here today. So it actually builds a big lookup table of all these exports from all these DLLs. And then it has a bunch of common hash hash algorithms that it runs across those names in order to build a lookup table for all the hashes. Now, like you guys saw in the last video here, REvil uses a custom hashing algorithm that doesn't, it's not covered by this tool. Now we could amend the tool to add our own hashing algorithm, which is kind of cool. But I thought for this video, what I want to do is to show you guys some first steps with scripting with IDA. So I thought it was better to leave this as a standalone tool for right now. So we'll just do it ourselves. So the reason why these DLLs are interesting is because they're probably the most common ones that malware would need to actually get the exports from. So we might be missing some DLLs in here, but this just saves us from enumerating every single DLL in the Windows folder. What we do then is we basically look at the Windows directory. This has to be run from a Windows machine. We look at the Windows directory system32, which has all the DLLs in it. We load them up one by one. We see if they're in the list, if they match the DLLs in the list. So we're only looking for these ones. Then what we do is we use PE file, which is a Python tool used for analyzing PE files. So we load up that DLL in PE file. We grab the export directory, just like we saw in IDA, and then we walk through the exports one by one, and we add the names to a list here called export list. And just for convenience, I turn this into a JSON dictionary, which I then save out to a file called exports.json. So this script I'll put on my gist on GitHub, and I will also put the exports.json output from that on GitHub, which I will link in the description below. So you guys don't have to do this step. Now again, this is pretty simple. There's lots of tools that do this. This is just a simple example. And all we want to do is get a nice long list of all those potential API names so that we can start doing our hashing. Now, the next thing we want to do is we want to transform these into a couple functions that we can use to build the hashes for all those names. So what we're going to do is we're going to walk through here step by step, transforming our code from our last video into a tool where you can enter a hash and it'll spit out the resolved API name.
So now don't click off the video. I swear to God, the code part's going to be like 20 seconds long. You can wait that if you don't click off the video, Ding Ding's going to hunt you down.
So the first thing we need to do is we need to grab some code here to open up the JSON dictionary that we saved. I'm just going to copy this over. So we don't need these. We can comment this stuff out. And let's open up our dictionary here. So we're going to assume that in the same directory, there's a dictionary called exports.json, and we're going to load it up in here. As you saw in the other script that I had open, where I built the dictionary, the actual key is exports, and that gives you the export list that we saved with that other Python program. So again, nothing fancy here, nothing special. Anyone who programs in Python, this is, no brainer. I should also mention that it's a little bit late to mention this, but you definitely need to know how to program in Python. Otherwise, this video is going to be useless. So I should have mentioned that before. You definitely need to know at least some basics programming with Python. Also, if you hear some weird noises behind me, it's not actually me. It's a very sleepy bulldog. You can see here. So he wants to be near me. It's cold out. I'm in Canada. It's wintertime. And so he's going to sleep peacefully back there and make a lot of weird noises. Okay, so moving on, we have pulled in the exports.json, and in order to do that, we need an import of JSON. So next thing we want to do is we want to take this list of exports, the list of API names, and we want to transform it into a dictionary that the key in the dictionary is the hash value, so this custom hash that REvil uses, and the value is the name of the hash. So then we can kind of look it up by keys. So to do this, we're going to create our API dictionary or export dictionary, and then we're going to, and then for each one, we are going to, this was get API function. I think this is actually so this returns the hash. So we pass in the name, and it gives us the hash. So I'm going to call this get API hash. So we're going to use this function. I'm just going to move it up to the top here so that it's already instantiated by Python here. And so we're going to use get API hash of the export name. And this is going to be the API hash. And then what we're going to do is we're going to add that to the export DB as the key, and the value is going to be the actual export name. All right. There we go. So now we have a built export DB, and what we want to do next, let's delete this out. What we want to do next is we want to create a function that is going to be able to look up hashes in this database. So we're going to create a function called def lookup hash, and this is going to be the API hash. And what we want to do is we want to actually transform it. So if you guys remember in the last video, before they looked up the hash, there was actually a transform. So I'm going to again move this up, our library functions, move them up. So we want to first transform it. So we're going to call this t hash, and that is the transformed hash, and that is API hash. And then we want to then look up that t hash and return it. So let's return the export DB. We're going to get that value, the t hash value. And if it doesn't exist, we're just going to return an empty string. So everything should work fine. There we go. Okay, so let's save this out, and then we want to test it. So let's open up our command shell here. I'll make the font a little bit bigger for you guys. All right, we'll cd into the desktop where we've been keeping this stuff. Start up Python, and we'll import JSON. And what we can do is we can actually test this whole script from the command line simply by copying it over. So what we'll do is we'll sort of copy it piece by piece here into the command line here, paste it in, paste in all this stuff here. All right, paste in the lookup function. Okay, so now that we have that built, let's test it out, and we'll try our lookup hash, and we'll copy our value over here, paste it in. Hey, it works. There we go, right? So this hash, as we saw here, corresponds to this API, and it works now. So we know that this right now is going to be able to look up each one of these hashes. So we could try another one if we wanted to. We just copy this over here. Hey, there we go. So we can now do this fully statically. So we now have a script that we can use to basically resolve all of these hashes into API calls. It's going to make reverse engineering a lot easier. Now what we want to do is we want to import that script into IDA here, and we want to automatically mark up the IDB, add those names automatically. Now, in order to do that, we're going to need to interact with IDA via the Python interface. So there's like a little Python bar down here, output console window, and you can also come in here and go to file, script file, and load up whatever files you want and run them. So that's what we're going to do today. That's the meat and potatoes of this video. And in order to do that, I want to introduce you guys to Alex Handel's Beginner's Guide to IDA Python. Alex is not paying me for this. In fact, you don't have to pay him either. So this is basically a book that provides really good documentation for IDA's interface, and it's free if you want. I suggest you donate a little bit to him. It's a pretty awesome book, and I think he deserves it. But if you can't afford it, it's free. So it's available here. I'll put the link in the description of the video below. So I highly recommend that you grab this book, and you can use it as a reference when you are building your own IDA scripts. And we're going to use it as a reference for this video. I should also mention, a little side note, one of the reasons why this video took so long is because, so I'm actually privileged to be friends with Alex, and I was trying to get him on here to co-host this video with me. But it turns out he is like the only research engineer I know who has a busier schedule than I do, so it just didn't work out. So I had to go ahead and make this without him. But maybe next time we'll have him on to talk about something else, maybe a little bit more advanced. So before we get into this, I need to mention something about IDA versions and APIs. So you guys might have noticed I'm using an older version of IDA. I'm using IDA 6.9.5. So this is before they moved to 64 bits and before they supported Python 3. So I'm using a much older version of this. It's just because my license expired. I didn't pay for it because work was paying for the other one. I don't want to use my work IDA for these videos because it's a personal thing. So I just have an older version of IDA. Now this means that I have to use an older version of Alex's book. I'm using, I'll just scroll up here. I'm using the third version of it, version 3. He's up to like version, I don't know what now, a lot, version 5. So the Python API for IDA has changed considerably since version 3. So be aware if you are using version 6 and below, 6.9, etc., then version 3 of this book is what you want. If you're using the newer versions, then you want a newer version of Alex's book, which has updated information for the updated APIs. Another thing to note is if you are just getting started with IDA and you're having a hard time getting the Python environment set up for IDA, so you're not able to do pip installs and stuff like that, this book will definitely help you. He has like step-by-step guide how to set that up, get everything working in the beginning of it. So again, highly recommend it. Today, we're going to be using version 3, like I said, And the two API calls that we're going to use from IDA to do this, they've changed in the most recent version of IDA. So again, if you're using the most recent version of IDA, make sure you check out the book and find the updated version of the calls that we're going to be using today. So if we look at what we actually want to do, all we want to do is we just want to read this address in, and then we want to relabel it. We want to change the name of it. So really all that is that's just two commands in IDA, right? So it's a read the address, and then it's a create a name for the address. And it turns out that both those API calls are actually in the IDC module for IDA. So let's let Alex explain this to us a little bit. There are actually multiple different ways to interact with IDA, and you can basically use the IDC module or API, which is just a wrapper for the C API for IDA. So this means that IDA's less than adequate documentation of its C API will actually map to the IDC Python module. You can also use IDA utils, which are like high-level utilities that can be used to do sort of multiple functions together, and the IDA API, which is basically like a way to interact with more low-level stuff in Python or in IDA, which I don't use too often. I usually use the IDC one. It's just basically the IDC is sort of almost a one-to-one mapping with the controls that you have here in IDA. So that's what I use. And so whenever I'm looking for a function, I'm usually looking for it in the IDC API. So the first thing we want to do is we want to actually grab some data from here. And these are D words, right? So they're, it's a 32-bit integer, a D word. So we're going to look for IDC D word. So let's do a Control F here, D word, and here we go. So here, the cool thing about this book is that unlike a lot of books that I can't stand technical books, they put me to sleep, where they're kind of written where there's like a story and you're supposed to like read it before you go to bed or whatever. This book is not that. This is like an instruction manual, which is much more my preference, where it's like a lookup reference manual. So you basically just look for the information that you need to look up, you need to understand at the moment when you're doing it, and this will give you sort of an overview of what's going on. So here we're talking about how to access data in IDA. We can see that they have all these different data size and type keywords. So we're going to use the D word, and we'll just test it out here on the command line. So we can do idc.dword. And if we look at our reference manual, EA is actually the address. So we're going to grab the address here, and remember to put the 0x in front of it. There we go. And what does it return? Well, it returns this number, and if we were to hexify it, that is our first D word, right? So we've already done the very first thing that we need to do in our script. We know that we can use idc.dword with an address, and we should be able to get some data here. So there we go. So the next thing we're going to need to do is we're going to need to rename these D words with the actual name of the API so that when they're used in the script, the name of the API shows up instead of the D word. So what we're going to do is we're going to look for a way to rename stuff. So again, looking in our IDC API.name, and we can see there is an IDC.name right here. And I think it's the only one in the workbook here. So IDC name. And that actually looks like it gets the name. Let's see if there's a way to make a name. Is it make name? Yeah, here we go. So we pass the address of the operand to blah, 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 and then print the newly named operand. So this is the prototype for creating a name. So put this in here and we'll give it a test. So that's the address again. So let's use this as an example and let's call it test. All right, we'll copy that into our IDA console here, paste it in, boom, renamed it. All right, so we now have our two ways to interact with IDA. We can read data out and we can write names into it. That's all we need to do in order to interact with our IDA here. So let's come back here. Now that we have the two functions to interact with the IDA interface, we can finish off our script here. So I'll just replace this here. These are just placeholders so that I don't forget the syntax. Okay, so now what we want to do is we want to look at how to automate this. So if we look at how it's automated here by the actual ransomware, it's probably going to give us an indication of how to automate it ourselves. Actually, I'm just going to Before that, press N, and I'm just going to delete this name so that it goes back to its normal. So let's do a xref into the IAT build function that, again, we analyzed in the last video. And we can see the way they do it is they loop through, so that's the pointer to the table of hashes. They loop through one hash at a time. So here's our loop, and they skip 4 bytes. So they're doing D words. D words are 4 bytes. So they're going 4 bytes at a time. So each D word. And they compare the counter, so that's the counter, to hex 230. So all we have to do is we just have to recreate that algorithm ourselves. So we have to create a for loop that goes through 1 D word at a time, and it loops through up till the counter reaches 230 hex. So let's just recreate that quickly in Python here. So again, those of you who are very familiar with Python will know immediately what we need to do. For pointer in range 0 to 0x230, I think. What was it? 230? Yeah, 230. And we're going to go 4 at a time. There we go. So now this is going to move a pointer through that range, 0 to 230 hex, 4 bytes at a time. So what we need now is we need that base address where this starts. So that is this address right here. I'm gonna make this a bit bigger so that we can actually see what we're doing here. So our base, okay. And so what we want to do is for each D word in that range, we want to actually get the D word. So this is going to be the hash value equals IDC get word at pointer at base address plus the pointer offset, right? So we're actually having the ransomware code do the work for us. We don't really have to think. We're just translating it into Python. So for each hash value, now we want to do a lookup of the hash. And so this is going to be the API name. Dog's making a lot of noise. And we're going to look up the hash value. And remember here we return an empty string if there is no hash. So if there is an empty string, so if API name is empty, we'll just continue our loop. And if it's not empty, if we actually got a result, we want to make a label or make a name at that address. So this is the address here, and we want to use the API name. Okay, so if I was to just run this script now, so I could save the script, a couple things would be a little bit wrong. So the first thing is we have a relative reference to that file, that JSON file, and that's not going to work because when we run our Python in IDA, we don't know what the relative path is, so we need to have an absolute path here. Now, one way to fix this is you can actually create a global export DB. So that's what I'm going to do here. I'm going to create this guy up here, and I'm going to create a function where we pass it the path to that exports.json, and it'll actually build the database for us. So we'll call this def setup. Okay, and so what we're going to do here is we're going to actually pass it in our JSON file here. And so that's going to set up this global exports DB in IDA for us, so we can then use it in IDA anywhere we want. Next thing, this address is hard-coded in the script, and of course that isn't going to work. You need to be able to change that address depending on your IDB, right? So obviously the address might change depending on how the malware sample is compiled. So we're going to actually change this into a function as well, and we're going to call it get imports. And we're going to pass it the base address instead of having it hard-coded. There we go. And this whole thing is going to be tabbed in. There we go. So now what we can do is this script has no dependencies. It has no relative paths. All we want to do is, I'll just clean this up a little bit. Okay, so all we're going to want to do is we're going to load this script up in IDA. So all these functions will then become available to us on the command line here. Then what we're going to do is we're going to run the setup script, and we're going to pass it the full path to that exports.json file, which is sitting on my desktop right now. And then we're going to call get imports, and we're going to pass it this address right here. And that should label all those imports for us. So we'll save this out here as part1.py, and then we'll load it up. Script file, desktop, part1.py, open it up. Okay, so now that looked like it didn't have any effect, and that's because all it did was it just interpreted that script, it loaded those functions up into IDA, and now those functions are available to us down here. And so what we want to do is we want to call setup and we want to pass it the path to our JSON file here that we created. Copy that path out, paste it in, escape the backslashes, .json. All right, so it's set up, and we can test that it's set up by just printing out that export db, right? So now we know that it's all set up. So now all we have to do is we have to call get imports, and we want to pass it this address here for the very first hash in the import hash list. All right, you run it.
Shit.
Yeesh, didn't work. Oh, shoot. Okay, so hello, Gus. So you can see that there's been some sort of problem here, and it says like the wrong number or type of arguments. So I think I know what this is. If we were to print out our export db again, I'll show you guys something. So see these little U's before the API name? That means that it's stored in Unicode, and the API takes ASCII. So this is something that you might run into in IDA. And if you do, there's a really simple trick. All you have to do is just come into our script here, and all we're going to do is we're going to just encode this as UTF-8. So super simple. That should work for us. We'll save it. Save. Here, we'll have to load that script again. Then we're going to set it up again. Get imports. Boom. Look at that. All right, so you might have noticed something else kind of cool here. So because we actually use the proper names for these APIs as Windows uses them in the exports, because we actually got them from the exports directories of the Windows DLLs, IDA has helpfully added the prototype for each one of the APIs that it knows. So IDA has a database of these. And then we can see here if we were to like do xrefs, go find this in our code, and look, now it's properly labeled, and it even has the prototype, as you can see. So this makes analyzing our code a lot easier. And if we were going to go to the start here, let's come into this function and five it. Look at that, nicely set API names. So there we go. That is how you statically automate the dynamic import address table. That's how you statically reverse it and label it in IDA. Now, the thing is, that might have seemed like a lot of steps, and maybe it was a lot of steps at first because we had to reverse engineer the algorithm, et cetera, et cetera. That could be useful later on, but the way that this really helps you in the future, and it is definitely super helpful, especially for something like REvil, where there are new builds coming out all the time. So you have to continuously reanalyze it to see what's changed. Is now going forward, anytime you have a REvil sample, you can just load this up into your IDA, and it's just 2 clicks to populate that entire tree of API calls here. So now we've done a bit of work, but now every single REvil sample that you analyze, you automatically get the imports for it. Super simple. Also, hopefully this was sort of an easy introduction to scripting in IDA. Again, we only use 2 API calls, and there are 2 API calls that you're probably going to use for most of the tools that you write in IDA. So reading out that information from the actual IDB, and then writing labels or writing names to the IDB. So hopefully you found that helpful, and hopefully this gets you started with scripting with IDA. Again, this is a huge time saver if you guys are reversing a lot of malware and you are sort of analyzing the same sample every couple months when things change in it. This is a super useful tool to have in your tool belt. Now, what I'm going to do to make this easier for you guys to learn is I'm going to put in the description of the video below copies of all the code that I've used and a link to Alex's book so you guys can actually reproduce this for yourselves. Now, you can go from the very first video that we have on this, Unpacking REvil. Then in the next video, you can work with us step by step to go through and analyze the algorithm that's used to actually create these hashes. And then in this video, hopefully you can reproduce the scripts in order to label your own IDBs. Also, before I take off, one last thing to mention. A friend of mine, Lars, wrote an excellent blog post about dynamic hashing in general using this sample. And so I will also link to that in the description of the video below. So yeah, hopefully this is helpful. and it will be a little bit of time until our next video, but hopefully our next video is actually us releasing our special project. So stay tuned. And until next time, keep exposing the mechanics behind the malware. Stay curious.